Let's discuss the finite state machines in Stateflow. First, we will compare flowcharts and finite state machines. Then we will discuss the state transition rules and the Stateflow action language with its transition action rules. We will see why inner flow graphs are better than state actions. And we will discuss the semantics of state events and temporal logic. Is Simulink not enough? Why shall we choose developing in Stateflow? Because in Stateflow you can model and simulate your functions just like in Simulink. But animation of the control flow in Stateflow makes the functions much easier to develop and to debug. Animations help understanding the complex functionality. You can design both the combinatorial and the sequential logic with flowcharts and state machines. You also can model reactive systems with events and time-based conditions. You can use external input signals and supervisory control. And you can generate production C code for both flowcharts and state machines to run it on the target hardware. The flowcharts are used for decision flows that do not require history. The state machines preserve local data and active state between updates. So, flowcharts shall be used for modeling combinatorial design, like stateless flowcharts. And state machines shall be used for modeling sequential design, like reactive or supervisory systems that depend on history. Finite state machines have a finite number of states and deterministic state transitions from one state to another. We will use only two extra objects, which are the state and the box. Here are the states. They look different than the junctions. The states can hold the historical information. They can be active or inactive. The state transition rules help to search for possible paths between states from an active state. The state is a value stored in a memory, just like unit delay in Simulink. The transition is a path between the states. The junction is just a branch of a transition. It's not holding any memory. The event is a conditional activation, and the action is a reaction on an event or impact of a condition. The step is the next action after the test of all paths from an active state. The transition search rules in this example start with the initial state, activated by the default transition. The default state will be initialized at the beginning of the simulation. In the next time step, all of the available exit paths of the active state will be tested. In this case, we have just one exit transition. The active state remains active if no valid path was found. Otherwise, Stateflow moves to another state. It deactivates the current state and activates the new state. In this case, it goes from off to on after testing the condition and executing the condition action. And it holds the history for the next step. The Stateflow action language allows mathematical and logical operations on variables, even though it's not very safe or easy to debug. You'd better use the Simulink for that. You can also implement the calls to external functions. You can use event reception and broadcasting to trigger internal or external components. The events can be exchanged by database conditions, which is very familiar to C programmers. There are some rules to follow when you use the Stateflow actions. The MISRA modeling guidelines prohibit the usage of the transition actions. They are not allowed, but you can use the entry or condition actions instead. We recommend the condition actions with curly brackets. Even though the entry action is allowed because of its compact view, it's not so good for reviews and for debugging because it will not be animated during simulation. So we recommend using the inner flow graphs instead. As you are already familiar with the flowcharts, you will understand the inner flow graphs immediately. The graphical modeling of state actions enables simple debugging because of the animation. Instead of the entry action, you can use the default transition. Instead of the during action, you can use the internal transition starting from the border of the state. You can use only one internal transition within any state for easier reviews. You can also use events and temporal logic in Stateflow. The temporal logic controls the execution of a chart in terms of time. The semantics is easy to understand. After 20 ticks, move from on state to off state. The tick is an internal event implementing a counter. For production models, we still recommend to use local counters instead of the tick event to achieve 100% MCDC coverage. You can also fire some external events like function calls to activate other subsystems. In summary, we discussed the difference between flowcharts and state machines. Now you know what are the finite state machines. You know the state transition rules, the Stateflow action language, the transition action rules, and the inner flow graphs. You also know what events and temporal logic should not be used. So let's go to our example and implement the state machine in Stateflow.